Hello everyone, welcome to my contribution of this year's The Hack Summit 2025. I named the session AKS Security is Simplified for Developers because I've seen many companies where developers have to manage everything. This means there are often no infrastructure or cloud platform teams, and with Kubernetes it's such a big complicated system that we could talk for weeks about security and how it works. And developers often don't have the time or the know-how to operate a cluster securely, especially when they're using any cloud environments. For example, we're going to take a look at Azure today. It is so easy to set up an AKS cluster. It takes a couple mouse clicks and the Kubernetes cluster is running. The downside is if you don't know what to do, it is very likely that you configure it in a very insecure way. So the plan for the next 30 to 35 minutes is I'm going to give you a couple best practices that will cover already a lot of the security concerns. If you implement them, I would say you're already 95 to 98% there for a secure cluster. But if you need like a very secure workloads, then it's not going to be enough. But I think for the most teams, it's going to be a great start. So today we're going to look first at the authentication and authorization. This is how we log in into our cluster and how we manage our permissions. Then we look into Entra Workload ID. This is the Kubernetes equivalent of managed identities, and we'll use it to access other Azure services without passwords. Then we're going to take a look at private AKS clusters. First we define what it is and how we can configure it. And lastly, we're going to take a look at the Azure Key Vault provider for secrets extension. That's an extension that will help us to synchronize our secrets from an Azure Key Vault into the AKS cluster. If you're interested in the slides, you can scan the QR code, or you can also find them on my GitHub page. Before I get started, a couple sentences about myself. My name is Wolfgang Ofner. I'm a senior cloud architect based in Toronto, Canada, and I focus on Azure, Kubernetes, and DevOps. In Azure, lately I focus mostly on security, governance, and architecture. If you have any questions after the session, feel free to always message me on LinkedIn. And if you're interested in this kind of topics, I have a YouTube channel where I post one video a week, every Tuesday, and I also have a blog where I also post regularly. With this said, now let's get started with the first topic, and that's the authentication and authorization. In Azure with AKS, we have three different authentication modes. So the first one is called local accounts with Kubernetes RBAC. The second one is Entra ID authentication with Kubernetes RBAC. And the third one is Entra ID authentication with Azure RBAC. So if you take anything from the session today, remember that local accounts with Kubernetes RBAC is the default option, but it's also the most insecure one, and the best one would be Entra ID authentication with Azure RBAC. And now let's take a look why the one is bad and the other one is good. When you try to create a new cluster in the Azure portal, then you will have this drop down on the first page. Even though it's right there, it's often overlooked, and if you don't configure it, it will select local accounts with Kubernetes RBAC. In a production environment, you should always use infrastructure as code like Terraform, Azure CLI, Bicep. There are a lot of tools out there, but there also, if you don't configure a mode, it will select the local accounts with Kubernetes RBAC. That's the first one we're going to take a look. So as I just said, that's the default one, and I can see the reason behind. Because if you use this one, it is very easy to access the cluster and to get your work done. The problem is that you don't have a link between Microsoft Entra and AKS. This is a big problem. For example, if somebody leaves the company, then you usually have a process, for example, deactivate the Entra account, and you would think everything is fine. But since there's no link to AKS, this means all the credentials in AKS are still valid. This means if I don't think about deactivating the AKS credentials, then this now former employee can still log in into the cluster. And since we don't have a link from Entra to our Kubernetes cluster, we have to use built-in Kubernetes authentication. This means we have to create service accounts, we have to use roles, role bindings, and it's a lot of Kubernetes know-how. As I said, I want to focus on developers, and I as a developer don't really care about all these Kubernetes features. I want to use my Azure features, my Azure tools, what I know. And if it's too complicated, it's unlikely that developers take the time to learn it or even get the time from management. Another problem is that the token with the credentials is stored unencrypted in the so-called kubeconfig file. The big problem is, since it's unencrypted, it can get stolen or lost very easily. For example, I could check it into Git by accident, or somebody could just see the file, take a picture, and then they can use this file to access my Kubernetes cluster. So if you take a look, that's how this config file looks. So on top, we see the server that's up here, but we also have the server certificate, the client certificate. And if I just copy paste this to a new machine, I don't even need to log into Azure CLI or anything. I just have this in my kubeconfig, and then I can already execute kubectl commands. So Microsoft recommends to use this approach only when you don't have your users in Entra. But since we're using Azure, and if I have guest users, I could just easily invite them into Entra, I don't see this as a use case. So my recommendation would be, use this if you want to try something out and you don't care about the authentication. For example, for my YouTube videos, if I want to show something in AKS, I just create a cluster because I know I'm going to delete it in 1 hour again. I don't want to deal with authentication right now. I want to focus on the topic I want to present in this video. So in this case, it's totally fine, but for a production workload, never use this approach. Since you could imagine, I said there's no link between Entra and Kubernetes. This means the user management is very difficult. I have to know how Kubernetes works. I have to know how to get the credentials to the developers. I have to remember if somebody leaves the company to remove their account. So this leads often to some problems. For example, that users have too many permissions, that users are still active even though the people already left the company a long time ago, and it can get messy quite easily. From a security perspective, it is recommended to just deactivate the local accounts, and then you can't have any accounts that could be used to access the cluster. This leads us to the next option we have. That's the Entra ID authentication with Kubernetes ABAC. As the name suggests, here we have a mix. First, we have the authentication with Entra. This means we have to log in with our Entra account. This is already great because now we don't have a token that could be stolen. Also, if somebody leaves the company, we deactivate the user account and this person can't log in anymore. So that's already a very big security improvement over the local accounts. But then the authorization still happens with Kubernetes ABAC. This means I as a developer still have the same problem that I have to know how it works in Kubernetes. The way you would set up this cluster is when you create a cluster with this authentication mode, then you have to configure an admin. This could be a user or a group. And once the cluster is created, then this admin will configure the roles and the role bindings for your user. Additionally, if somebody should be able to download the credentials, then this person or group needs to have the Azure Kubernetes cluster user role in Azure. The permission to download the credentials is also part of other roles, for example, of the owner or contributor role. But the Azure Kubernetes cluster user role, which is a horrible name, but this would be the least privileged role needed to download the credentials. So if you remember, if you have this set up, somebody tries to download the credentials, they get an error message, they're not allowed to perform this action, then assign this rule and they will be able to download the credentials. So once they have the credentials, they can try to execute kubectl commands, and while they do this, Kubernetes will check what permissions they have. And to do this, we can either use built-in roles. For example, AKS has a lot of built-in roles such as admin or viewer, but we can also define our own roles. If you take a look at this, it's very complicated if I'm not an expert in Kubernetes, because I have to know that there is this role I can define. This is kind of easy, but then I also have to know that there are API groups. Inside these API groups, I have resources, and then also have verbs which I can apply on these resources. So in this case, for example, I have to know that in this API group, I have a resource called pod. And if I want to read the pods, it's not just get, there's also list and watch. So all of these three commands are just for reading. And if I continue, there are even more API group, more resources, so it can get quite complicated quite easily. As you can see here, it is just for reading. But usually in a production environment, it's way more complicated than this. So I have reading on many resources. Sometimes I might have edit rules, and there's so many resources inside of Kubernetes that it can get really complicated. But let's say you configured your role, then you also need a role binding. So that's the second resource, and this is the link of the role, which we just defined, and an Entra user or group. Something that's not that nice is that this link is via the ID in Entra. So here we have the Entra ID of a group. This means I have to go back to Entra, figure out what is the ID of whoever I want to assign these permissions, and then I can assign the permissions. Additionally, we have the concept of role and role binding, the same as cluster role and cluster role binding. So one role and role binding is for a namespace. This means it only exists within a specific namespace, and the cluster role and cluster role binding is for the entire cluster. This means if I only configure it for one namespace, I don't have permissions for the other namespace. But once I configured all of this, it can look like this. So a developer executes a kubectl get all command. Then we'll see there's one pod running because we have the permission for the pod. But we can also see there's an error message for replication controller and also for the horizontal pod autoscaler. As we have seen, it's quite complicated to manage the users, but it's still easier than the local accounts option we have seen as the first option. So if you have to select between these two, always select the Entra ID with Kubernetes RBAC. But in general, I only see one use case where you would want to use it, and this is if you have an Arc enabled Kubernetes cluster that's not AKS. So Azure Arc is a service with which you can manage a Kubernetes cluster that is running outside of Azure. This could be an on-premise Kubernetes cluster or also a Kubernetes cluster with a different cloud provider like GCP. There you can use Azure Arc, and then you have a link to Azure. And with this, you could use the Entra ID with Kubernetes RBAC authentication mode. So you can log in, for example, into your GKE cluster with your Entra ID. But this is a rare use case, and I haven't seen it used in production at all yet. The problem with this approach is, as we have seen, the auditing can be really complicated because I have to look at all cluster role bindings, but I also have to look into every namespace for a role binding. Then I have to find the IDs, go back to Azure, look up the IDs in Entra, and then I know who has access to a namespace or the entire cluster. What's nice, but that's just so common in Azure that not even worth mentioning, is that I can assign permissions to users and groups. But again, it's just IDs, so it's very hard to figure out who has access. And all of this leads us to the best option, the Entra ID authentication with Azure RBAC. This is the best option because we manage everything with Azure. This means we have Azure RBAC, what we are using for our subscriptions, for our other Azure services. and we can use whatever tools we already have in place. So if you're using Terraform, we already know how to assign permissions. And since everything is managed in Azure, that's the recommended way by Microsoft. And also from my experience, it's by far the easiest way to manage your AKS cluster. Again, as I said before, if you want to download the credentials, you need the Azure Kubernetes Service Cluster user role. But there are some rules that already have it signed in. For example, if you take a look here on the right side, here we have the Azure Kubernetes Service RBAC Cluster admin, and this admin already has the role built in. Then also what we as a developer are already used to in Azure, we have either built-in roles or we have custom roles. So if the built-in roles are not suitable to our needs, then we can create custom roles and assign them. The built-in roles have everything what you're used to, like an admin, a reader, a contributor. So to get started, that's probably enough, but who knows, maybe in the future you need your own roles, then just create it and assign it. The only downside, I'm not even sure if it's a downside, is if you want to assign the permissions to the entire cluster, you can do it in the Azure portal, and you can also see it in the Azure portal. But as I said before, we should also use an infrastructure as code tool. And if you want to assign permissions to a namespace only, then you have to use the Azure CLI to do this. Also, you can only use the Azure CLI to display permissions on a namespace. You can't see it in the Azure portal. But that's the only downside. So if you have to decide which option you should choose, always pick the Entra authentication with Azure RBAC. Now that we have the login managed, now we take a look at Entra workload identity. Before we do this, let's talk about managed identities. In Azure, we have the concept of managed identities. This means we assign this identity to an Azure resource, and then we can use this identity to give permissions to other resources. For example, if I have an app service and a database, I can assign an identity to the app service and then assign this identity permissions to access the database. This is great because I don't have to manage any username or password. So back in the old days, we had username and password to log in into the database, but then we had to store them securely somewhere. If other developers needed access, we had to find a way to share it. We had to provide it to our app service, and we also had to take care to regularly rotate it. Because if somebody gets access to the password, they can access our database. With managed identities, there's nothing that can get leaked or stolen, because the identity is assigned to an Azure resource. The problem with AKS is a bit that we can assign an identity to the AKS cluster itself. That's great if we want to, for example, have permissions on the container registry to pull images. But by default, we don't have an option to assign an identity to a pod or a deployment inside the AKS cluster. For example, if we have two applications, one for the test and one for the production environment, I want to have different permissions. The dev environment or the test environment should have access to the test database, and the production environment to the production database. And with the normal concept of managed identities, this is not possible, but therefore we have Entra workload identity. So Microsoft had different approaches in the past. One time it was called pod identity. Then there was also another solution. And Microsoft took these learnings and created Entra workload identity. And with this, we can assign an identity to our pods. Or we can also assign to the deployments. And if you have multiple pods, we have the same identity on all the pods. What's great about this is it's also very easy. So all we have to do is enable the OIDC issue on our AKS cluster. This stands for OpenID Connect. That's a standard. And we can do this with a new cluster, or we can update an existing cluster. Once we have this, Then we can create a match identity. And inside our AKS cluster, we create also a service account, and then we can link them. The way we do is we have an annotation and a label on the service account, which has the ID of our match identity. And then also we tell the pod of our application to use the service account and use workload identity. I know it sounds complicated if you don't see an example. Unfortunately, we don't have enough time today that I show it to you. If you're interested, you'll find on my YouTube channel a detailed video where I tell you step by step how to set it up. But if you take a look at the workflow, how it works in a bit simplified terms, so the first 3 steps are to get the access token. So our pod has a link to the service account, and the service account has a link via federated credentials to the match identity. And if our pod needs an access token, then Kubelet sends this token to Entra, and then Entra uses the OIDC connection to check if this token is valid. If the token is valid, then it will send back an Entra access token, and then our application can use this Entra access token to access other Azure services. For example, a database. With this approach, we have the identities, we can give permissions to the identities, and we don't have to manage any passwords. Next up, we have our private AKS cluster. And this can be a bit confusing when you talk about the wording private AKS cluster. All it means is that the API of the master node will only be available over a private connection. Technically, this means that AKS creates a private endpoint and then attaches this private endpoint to the AKS VNet. If you want to access the API, you have to go through this private endpoint. This also means all the communication of the worker and master nodes are over private connection. So if you have the API private, nothing changes in the connection between master and worker node. So if you take a look at our Kubernetes resources, and on the left side in the red box, we see our master node, which is the brain of our AKS cluster. Then in the blue box on the right side, we see our worker nodes. That's usually virtual machines in Azure where we run our pods and our workloads. And if you talk about making the API private or the AKS cluster private, then it's only this API in the green box that we are making private. Just to be clear, since I've seen some confusion in the past, this doesn't mean that the entire cluster is private. So if you have some workloads, for example, a website that is publicly available, then this still works the same way it worked before. Also, if you download images from Docker Hub, this also works. Nothing changes, only the access to the API. This means we have to find a solution how our developers, but also our CI/CD tools can access the cluster. For our developers, we have multiple options, and the best option depends on what solution you already have in your environment. So the first option could be to use Azure Bastion and a jump box. So Azure Bastion is a service which allows us to connect to a virtual machine over a private connection. This means we connect via the internet to Azure Bastion and then over a private connection to the jump box, which would be an Azure VM. What's great about this approach is that the VM doesn't need to be accessible from the internet, and therefore we keep it secure. So if you take a look at the entire architecture, you can see it's quite complex just to access our AKS cluster. So on the right side, we have here our AKS cluster, we have the private endpoint, the AKS VNet, and also on the bottom, we have here the private DNS zone. Now we have to create Azure Bastion, we have to create the VM, then usually we have our own subnet and VNet for both of these resources. So this would be all here in the blue box. Then since it's a separated VNet, we would need VNet peering. This means that our VNet has access to the AKS VNet, and we would also have to implement the private DNS zone so we can resolve the DNS name of the private endpoint. So as you can see, a lot of resources involved. If you knew this concept like private DNS, VNet management, it can be really complicated. Also, it can be a bit expensive, especially if you're a smaller team, because you need Azure Bastion, the VM, manage the VM. And that's why I said it depends on your environment. If you already have Azure Bastion set up, then this might be a good solution. If you don't have anything, then it's probably an overkill to set up. Another option would be to use the easy AKS command invoke command to wrap your kubectl commands. So if you take a look here on the right side, we use this Azure CLI command. We provide the resource group of our AKS cluster, the name of our AKS cluster, and then we can wrap the command we send. In this case, kubectl get namespace. This works. I don't need any additional resources, but it can be quite annoying to type all of this. So if I want to have the next command, I have to type all of this again. So it works, but it's not very great to work with it day by day. Additionally, you could also use the Azure portal. There you have, if you go to your AKS cluster, I think it's called run command, the tab, and there you can just send kubectl commands. Also, this also works, but again, I as a developer want to use my own tools. So this might be okay if I don't have any other options, but it's not the best solution, I would guess. Then the third option is if you already have a VPN connection or an ExpressRoute connection. So ExpressRoute is a private connection from your data center or on-prem location to the Azure data center. The downside is that your ISP has to configure it. So if you already have it in place, that's great. If you don't have it in place, it's probably again an overkill to configure. The same with the VPN. If you don't have it, you would need a VPN gateway on Azure, and you also have to have the connection from your developer machines. So it could be either a site-to-site connection from your on-premise location or a point-to-site from all the developer machines. But again, it's a lot to set up. It can get expensive if you have a lot of traffic. So again, not the best solution. And fortunately, we have a new feature that's still in preview, but I didn't have any problems using it. And this is using Azure Bastion to connect directly to the AKS cluster. This means we don't have to care about the VM, the private DNS zone integration, and so on. So if you take a look at the architecture again, then all we need is our AKS cluster. But if we make the API private, then we already have the subnet, the private endpoint, and the DNS zone. So we don't have to care about it. Then we don't need this jump box. We don't need a VNet integration. All we need is our Azure Bastion. And this can be either inside its own VNet or inside the AKS VNet. If it's inside its own VNet, then we need the VNet peering. And if you use it inside the AKS VNet, then we don't even need the VNet peering. All you have to pay for this is for Azure Bastion. You don't have to manage anything. So my suggestion would be, if you don't have anything configured or set up yet, then this might be the best solution to connect to your private AKS cluster. For the CI/CD pipeline, there are different approaches, and again, depends a bit on your setup. Probably the best solution would be to use the GitOps approach. This means you have a GitOps agent inside your cluster. The most popular tools are Argo CD and Flux CD. My personal favorite is Argo CD, but both are great. They're very popular. And the idea behind is that this agent connects to a Git repository and then monitors this repository. If there are any new commits to the repository, the GitOps agent will pull it and then apply the changes. Therefore, you don't have to connect to the cluster directly, but you still have automated deployment. If you're using a normal CI/CD tool, for example, Azure DevOps, then you have managed DevOps pools. This allows you to have a self-hosted agent and you can add it to a VNet and use this connection to access the private endpoint. If you have a different tool like GitHub, GitLab, then you have to self-host your agent or runner. And this is probably on a VM because we don't have much DevOps pool for these tools. So probably you would have to set up a VM, install your runner there, and have the VM in the same VNet or in a peered VNet, and then use this private connection to access the AKS cluster. Next up, now that our AKS cluster is private, it would also be great if our container registry would be private, because if everything is private, it's more secure. If our container registry is publicly available and an attacker gains access and uploads a malicious image there, then our AKS cluster would download it and would run the malicious image. This means that an attacker was able to have malware inside our cluster without having direct access to the cluster. In Azure, it's quite common for teams to use the Azure Container Registry because it's by default a private registry. Everything is running inside Azure. We can use the tools we're already using. So it's great to keep everything private. But by default, it's available from the internet. This means if I have the right credentials, I can just log in and download or upload images. But as I said, it would be great if everything was private. So if you take a look, by default, I as a developer or also an attacker can access the container registry over the internet. And what's also a bit, I don't want to say weird, but let's say special, is that if you have an AKS cluster, that this cluster also pulls from the public endpoint. This means the connection goes over the internet, even though if both the Kubernetes cluster and the container registry run in the same Azure data center. But if we switch to a private connection, the way it works in Azure is again with a private endpoint. Then our AKS cluster can pull images over this private connection, and the developers, but also the attacker, don't have access to the container registry anymore. What's really awesome about this is that we don't need any changes in our AKS cluster, because with the private endpoint, we also get a private DNS zone, and then the AKS cluster can resolve the private endpoint over this private DNS zone. Like technically it works like that the private DNS zone overrides the public DNS entries. So our AKS cluster doesn't need any changes, but again, what we have to think about is our build agents. In Azure DevOps, as I said, we have managed DevOps pools. With other tools, you would have to find a way, probably over VMs. If you're interested in managed DevOps pools, I have multiple videos on my YouTube channel where you can see exactly how we do this. Configure a private endpoint and then use the private connection to access resources over the private endpoint. So before we run out of time, the last topic I want to talk about is the Azure Key Vault Provider for Secret Store CSI driver. That's an extension for AKS with a horrible name, but what it helps us is to match our secrets. So before I said we use match identities so we don't have any secrets, but sometimes we use, for example, a third-party API where we need an API key to access this API. So sometimes, even though we don't want to use them, we have to use secrets, access keys, certificates, and the way we store it in Azure is inside the Azure Key Vault. But now we have to find a way how we get it from the Azure Key Vault to our applications inside the AKS cluster. One way would be to tell the developers, just program it that you read it from the Key Vault. This works, but it's not that great because the developers now have to think about where to get the secrets from, how to download them. Maybe I have to give the developers access. So that's not a great option. And with this extension, I can mount the secrets, the keys and the certificates. This means everything inside the Key Vault to our pods. So this can either as a volume, but it can also be as an environment variable, depending on what I configure. What's great about this, I can also have auto-rotate secrets. So if I change them in Key Vault, I can automatically update them inside the Kubernetes cluster. Here it depends a bit what application I have. For example, if you use .NET, then .NET only reads the environment variables when the process starts. Therefore, I would have to restart my pod. But the other languages, they could read it on the fly. And also an awesome feature is that we can also create Kubernetes secrets. This means we have our Azure Key Vault secret and we sync it in the Kubernetes cluster and create there a Kubernetes secret. This might sound a bit counterintuitive because you already have them in the Key Vault, but it's very useful if your Kubernetes cluster is not always available on the internet. Or to be more precise, the Key Vault is not always available for your Kubernetes cluster. For example, if your cluster is on a cruise ship or a plane, if you're at the airport, you can sync all the secrets, and when you're in the air, you don't have a connection to your Key Vault. Since the secrets are in your cluster, your application doesn't care and still has access to them. If your application was trying to read them from the Key Vault, then the connection would fail and maybe even your application might crash. The last advantage of this approach is separation of concerns. Even if you're a developer team and you don't have an operations team and you might never get it, it's still nice to have a mix of operations and development. Also, as we will see on the next slide, the developers don't have to care where the secret is coming from. They only have to care that the secret will be there when the application starts. Now let's take a look at the workflow when we create a pod and how we can attach our secrets. So first, the Kubernetes API tells Kubelet to create a new pod. Then Kubelet tells the secret store CSI driver to attach a temporary volume for our pod. And at the same time, it also tells the secret store CSI provider to load all the secrets. And our extension for the Key Vault is the secret store CSI provider. This means we just inject it into this workflow, and then we download our secrets, certificates and keys from the Azure Key Vault via a secure gRPC connection. We return it to the CSI driver, and then the CSI driver attaches it to our pod. And here depends how we have it configured. It can be as a volume, environment variable, or as a Kubernetes secret. Our application starts, and the application doesn't care because it reads for example, .NET reads automatically environment variables and secrets. If they're there, it reads them and everything is great. So this is everything I wanted to show you today, but there's so much more when it comes to security from the Azure side, but also if you dive more into the Kubernetes and Linux side. And in the next two slides, I just want to give you a list of features and tools you could look up yourself if you want more security. So first, on the Azure side, we have Azure Linux as the secure operating system for our master and worker nodes. We have the SSH access, we have Azure policies, we have the Microsoft Defender, and we also have AKS Automatic, which is already a production ready pre-configured AKS cluster by Microsoft. If you want to go more into the Kubernetes and Linux side, you can take a look at pod privileges, at the security context. This means you can limit what the pod is able to do. And if you want to dive even into the Linux system calls, you can take a look at SecCom, which is called secure computing, where you can really lock down what your pods can do. But as I said, we can talk about this for weeks. For now, I would say if you focus on the couple topics I presented today, especially the Azure topics, then you will already have a way more secure cluster. And for average applications, I would say this might be already secure enough. Obviously, we can always do more for security, but this is already such a great improvement over like the default configuration. So you might already be happy to go and focus on other features. With this, You can again scan the QR code for the slides. If you have any questions, feel free to always contact me. If you're interested in these topics, you will find more on my YouTube channel. And I wish you a nice rest of the conference, and I hope to see you next year again.